All right, let's go ahead and get started while Andrea is testing his screen. Yes, it works. Thank you. Welcome everybody to our first community meeting for a while. So since we joined CNCF as a graduate project, we haven't had a user community meeting. So on behalf of the steering committee, we are working hard to restore user community meeting for everybody. This is the first one, and we do expect to have more on Thursday. Probably not in December, because December is a slow year, but we do expect to have more early next year also. So welcome everybody. This is supposed to be engaging and interactive. So if you have any questions, do raise it in the chat and we will bring it up as needed. So a quick introduction about myself. So I work at Solo, leading the open source team. I've been a very long time contributor, one of the founding members in the community, wrote 2 books about Istio. A little bit fun fact I always tell about me is I actually own a lot of IBM patents, 207. So I contribute these patents while I worked at IBM for almost close, a little bit less than 20 years. And of course, these are IBM owns all that. So I don't have really ownership other than I'm the co-inventor on these patents. With that, I am going to pass the mic to my speakers, co-speakers. Go ahead, Xuan and Andre. If you're muted, please unmute yourself and give a quick intro.
I'm Shoaib. I'm a Linux CNCF mentee for Istio performance testing, and my mentors are Linson and Andrea here.
Awesome, thank you. Andre, do you want to say something about
Sure.
yourself?
Yeah, so I'm mentoring. So he's really good. So it's been really fun working with him. Yeah, and I just joined Istio like 2 years ago. So I'm not got that much experience, but it's been really great working on it so far. And
That's
it.
awesome. And you already mentored new folks. So we so much appreciate that. Peter.
Sure. I'm a platform advocate also from Solo, like Lynn. I've been in the, say, Istio and service mesh world for the couple of past years. I don't know. It's always hard to say. You're always thinking it's only been like 2 years, but it ends up being 5 or 10 or 20, but not with Istio. But it's been a while that I've been involved in Istio and just cloud native and Kubernetes and everything. But yeah, I've been working with Istio a lot, doing a lot of content around Istio, workshops, trainings, talks, etc. So yeah, find me on Twitter and have my links there. If anyone wants to connect, I'll gladly connect with you.
Awesome. Thank you, Peter. I am so excited to have these wonderful contributors in the community to run the meeting with me today. So we've done the speaker intro, and then we're going to talk about what's exciting about Istio 1.20. And then we're going to show you some interesting demos. And then also we have Andrea and Shura talk about the performance of 120. Then we're going to open up for questions. So with that, I would love to kind of pass over to Peter to kind of talk about Gateway API, which I believe is one of the most significant change in 1.20.
Yeah, so if you can switch to the next slide. There you go. I don't have a lot here, but so the Gateway API has been like in Istio, been trying to get it implemented for a while as well. It's been like in beta, but then it graduated back in October, I think end of October, I would say. Gateway API graduated to version 1.0. So what that means is that we can now use stable set of the Gateway APIs in Istio to configure gateways and manage traffic, right? So what 1.0 20 brings is it brings the support for configuring authorization policies, request authentication, telemetry, and WASM plugin resources. So you can now configure these through the target ref field. So you can create an authorization policy, and I'll show this in a demo, and then use target ref field to point to the gateway that you want to apply the authorization policy to, I guess. So that's all I have. Like, it's a very short slide, but it's Gateway API is the way to go. If you haven't looked at it yet, it's time for you to start looking at it. I know there's a little bit of confusion in terms of the naming. So we have in Istio, we have the gateway resource. Then we have the Ingress gateway. People are talking about the Ingress gateways. People are talking about the Ingress resource. And now we have the Gateway API. So as I go through a demo, I'll try to like explain these a little bit more, but it's just a naming confusion. If you stick with the right name, you're going to be okay. So yeah, but it's definitely exciting to see this land in 120 and well, Gateway API getting to 1.0 and then Istio being fully supported by Istio as well. So yeah, and I think we'll go to the demos later, right, Lynn?
Yeah, so maybe we'll go through a couple of changes here. And I honestly, I think the Istio team has done a fabulous job on documenting what's new. The release managers have been amazing. So certainly we're just highlighting a couple of interesting features that we thought was really interesting. For me personally, the external name update is just so important to this new release, which I will also pull out a demo to show you, and traffic mirroring to multiple destinations. I think it's really interesting also, but the release actually contains way more than these features we're going to highlight today. So for instance, be able to support the network extensibility for network filter for WASM plugin. That's very interesting. So I want you all, if you have played or look at the release notes for 120, please do comment in the chat and let us know, what is interesting from your perspective, right, on 1.20 release. So please do let us know. With that, Peter, I think I would like to turn to you for the gateway demo. I will stop sharing.
Okay. Let me find my bearings here and I'll share my terminal. This one. Okay. Hopefully everyone can see it. It's just my terminal, nothing exciting yet. But so what I have is I have a cluster, local cluster that's running. I haven't installed anything yet. Well, I'm lying. I installed Metal LB just so I can get the an actual external IP address for the gateway. But other than that, it's just a pure kind cluster. So the first thing that I'll do is I'll install, I have Istio 120, right? Download it. And what I'll do is I'll install Istio with a minimal profile. So minimal profile is just the Istio-D. So no Ingress gateways, no nothing else, just Istio-D. The reason I'm doing that is because we'll use the Gateway API to deploy the Gateway API gateway resource to get an Ingress gateway instance up and running. So I've labeled the namespace as well. Let's just double check that everything is there. And the only thing that I have in Istio system is Istio-D. So the next thing that you'll have to do is, if you want to play with the Gateway API, is you'll have to download and deploy the Gateway CRDs, Gateway API CRDs. Notice the magic thing here is the version 1, and it's not the experimental branch either, right? So I'll have to enter my password here. And then this will just install the CRDs. Now, if you're not using, when you weren't using the Gateway API, the way that you would configure an Ingress gateway, you would install Istio with an Ingress gateway, you would have an Ingress gateway already running, and then you would use the gateway resource, Istio's gateway resource, to configure the hosts, right, and the ports where you want to open up the Ingress gateway. Now I'm going to create a gateway resource as well, but this time this is going to be the gateway API's gateway resource. And this is where that confusing part comes in that I was talking about. So notice that it is a gateway resource, but it's coming from the gateway networking kubernetes.io instead of the Istio's API version. The resource looks different from the Istio's gateway resource as well, but functionally it's the same thing, more or less. We're saying that the gateway class is Istio. This is just so the Istio-D can go and then provision the Ingress gateway for us once we deploy this. And then we're defining the listeners. We're specifying the host name, the port protocol, and then we're just saying we're allowing routes to attach to this gateway from all namespaces. Let's do that. So once I've deployed this, you'll notice that I'm getting a gateway Istio pod. Actually, let me look at the deployments rather. So gateway Istio deployment is created in the default namespace because I didn't specify another one. And this is an actual gateway instance now, right? Ingress gateway that I have. So at this point, this would be almost equivalent to if I would install Istio with a demo profile, right? That already has an Ingress gateway running, right? So next thing, I'll deploy HTTP bin just so we can access something or expose something. And then I'll use one of the gateway API's resource called HTTP route to expose this HTTP bin service that I deployed. Now let me just see that it's getting deployed. There you go. So it's up and running. So I'll use HTTP route. Let me just paste it here so we can see it. Use the HTTP route resource to refer to, well, to add a reference to the parent, which is the gateway in the default namespace. And I'm saying this gateway, this route is for http://bin.helloworld.com. Remember, my gateway resource was star.helloworld.com. And then I'm specifying the routes here. I'm doing a match and a path prefix. And then in the backend references, I'm just saying, well, route the traffic to HTTP bin service on port 8000. So this HTTP route basically does the work that virtual service did before, if you're not using the gateway API. So let's deploy this. Now, if I send a request to, let me just get the service IP. So this is what MetalLB did. So I can do host http://bin.helloworld.com. And let me just do headers. Right, there you go. So I get back the response through this host, right? So it's routing to the HTTP bin service. So this was there before. What's new in 120 is that, let's say I want to apply a authorization policy. So what I can do is I can create an authorization policy just like I would normally, right? But then I can use the target reference and point to the gateway to say, apply this authorization policy to that gateway resource, right? And then everything else down here is the same as it was before. So if I would do this still works. However, if we try to create another route, so I'm creating another route for the host name headers.helloworld.com and then /headers on the path. So if I try to do this headers call with headers.helloworld.com, I'm going to get RBAC access denied, right? So this is how you could then also configure with that parent ref, or sorry, target ref section here. This is now also supported in request authentication, telemetry, and the WASM plugin resource as well. So yeah, so this was the new thing that came in 120 in terms of the gateway APIs.
Awesome. Thank you so much, Peter, for that great demo. And I guess I would shout out to Keith Matrix that has been driving some of these changes in upstream along with his team. So excellent work on that. With that, let me share my screen back. One of the other most important feature, I believe, is external name support. Let me turn this into slideshow mode. So what does this mean, external name support? If you ever use Istio Analyze to analyze your resources, you might be able to see this error message or warning message in the past. When you use external name service in Istio, even though you may be just using it in your Kubernetes cluster and have nothing to do with Istio, it actually has a very, very bombing effect on all of your other services workloads in the mesh, because when your external name has TCP named ports, all the unmatched traffic for the ports serving the TCP is being forwarded to the particular external name service. So this is like, if you ever remember seeing some issues in GitHub, John had an issue where there's like 8 issues he aggregated while all these people complaining about surprising behavior about external name. And most recently, if you saw this tweets from Darren, where he complained about how mad he was with Istio, and I believe some community member of Istio, maybe Christian, follow up with him to.
Lynn, sorry,
Yes.
are you supposed to be sharing the screen?
Oh yeah, it's
because we don't see anything.
Oh, I'm glad you reminded me.
Yeah,
so sorry. I was talking about these issues, and I was also talking about the external name service in Istio Analyzer. Thank you, Peter. And I was also talking about this tweets from Darren, where he ran into issue related to external name and generate a lot of negative impact on Istio. So thankfully, in 1.20, John made a change to make this introduce an environment variable to fix this in Istio D. So we're going to talk about how that works today. The other thing really interesting is traffic mirroring. So if you look at our documentation, the mirroring is probably one of the most complex of our documentation under, I believe it's under virtual services, when you configure mirroring. So if you go to search, might be the fastest way. If you search on Miro, there are like multiple ways you can do mirroring, which you can use Miro to a particular destination. But now with 1.20, you can mirror to multiple destinations with the new Miro policy, which you can find out how to use that in the reference section. Unfortunately, we didn't have time to update the doc yet. But if you go to the reference section and if you check the Miro policy, you'll probably find it here. Let me see if I can find it quickly here. Maybe search works better. Okay, there we go. Yeah, by the way, this is super confusing. You can do Miro, you can do Miros, you can also do Miro percentage. The reason is when we initially added Miro support, Envoy only supports forward to one destination, and most recently Envoy added support for forwarding to multiple destinations. That's why there's Miro and Miro S. And then with the new Miro policy, you can potentially specify percentage inside of the policy. So, which is why, you see percentage here and also percentage, Miro percentage there. All right, with that, I'm going to show you more demos on this. Let me see if I can share my screen properly. So Peter, do let me know if you have trouble to see my screen or anything.
Yes.
Yeah, because I've been having trouble with my machine, so I ended up So I ended up rebooting my machine right before the meeting. So hopefully everything is still okay. So what I'm doing is you probably see my screen now, except it's empty. Is that right?
Yep.
All right. So what I'm doing is I'm bringing up my Visual Studio Code onto the machine. Can you guys see it? Or is it good size or it's too
Yeah.
small?
I would make it a little bit bigger, just
Okay. Let me
I mean,
do
in
that.
like Command plus, I meant make the, yeah,
This.
there you go. The font's
All
bigger.
right.
Yeah.
So now it's okay now? All right. All right. So essentially what I have right now in my cluster, I believe I already have Istio installed. So you can see I have Istio, sorry. I have Istio installed. I have, let's see, I have ingress, egress. I think I installed the demo profile. I also have Kayali installed. So that's all I have installed. So the first thing I'm going to do is I'm going to show you the what happens with the external name service, because that's pretty easy to hit when you have this problem. So essentially what we're doing is we're creating a demo namespace. We have Istio injection enable, and in this namespace, we're just going to deploy a cur pod, right? So all it does on this pod is just going to provide in this particular cur pod to allow us to cur it. So let me go ahead, deploy that. If I can type, all right, if it works. All right, so let me go back to my K9S. I can see the curve pod is coming up in the demo namespace. The second thing we're going to do, remember we go through about how this would have like drastic impact to your mesh, right? So what we're doing is we'll deploy a new namespace in a different namespace, and we'll just deploy a bad service, which essentially is just an external service. If you notice, the service uses nothing from Istio. It's a plain Kubernetes service. It just have an external name, which points to google.com. So let me go ahead and deploy that. So one thing really interesting was showing is I probably should have done a deployment sequence a little bit differently. So what I should have done is I should have actually, show you how it works without the bad deployed, right? But let me show you how the bad works now. So since I already got there. So basically, before I deploy the bat.yaml, right? So everything should work as a cur pod. I should be able to go to http://bin.org and get this. But the moment I deploy, I'm actually going to show you. I'm going to delete that to show you this. So the moment I deploy this bat.yaml, what happens is essentially when the curpod trying to talk to HTTP being, look at here, it actually failed immediately with subject alternative name doesn't match HTTP. The reason is it's trying to think it's trying to go through google.com, right? So this is all caused by this particular YAML. So what I can show you is, which I should have done, actually run the curve command before I deploy this is, so if I remove this, you can see I can run the same curl command again, and it just works totally fine. So, right, this is only a problem when you deploy this particular external services to the cluster, so which I will deploy now. So this is the issue with external name where people complain about that 8 issue. So in 1.20, there is a new function, which I do have a configuration with that new function turned on. So if you go to manifest file, I have, if I can remember where I put it, I have a demo, updated demo YAML where I enable that particular function. It's called enable external name alias. So what this does is you can, Istio can treat external name service transparently in your cluster. So you don't have to make any changes to your cluster, to your external name service. You don't have to name it to be like the right port. It's going to be more transparent to you. So so what we're going to do next is we're going to try to install this command with this updated profile to kind of update our Istio with that particular configuration. All right, so this should pick up and you can verify it's picking up. Sorry, you can verify it did pick up in the Istio D side. Let's double check on that. So if you go to Istio D here, so this is the logs, right? So if I do description of Istio D, and if I check the environment variable of Istio D, you can see this enable external name alias is set to true. So it should take effect. And what we're going to do next is let's go ahead and run the code command, right? Remember now I have the bad deployed, right? So without before 1.20 enable this flag, it would have broke my cluster completely for anything goes to when any of my pods in the mesh tries to reach outside of my cluster. Not right now, you can see with that external name alias enabled, this particular command can run successfully, right? So this is an extremely powerful function. If you're using external name service inside of Kubernetes right now, I definitely highly recommend you to try this. In fact, in Ambient, we're just having a meeting yesterday looking at using this function for Waypoint as well. So yeah, so that's my first demo. I do have another demo, but I do want to get to Andre and Shu up first for the performance. And if there's more time, I will go to my second demo on traffic mirroring. So Andre, do you want me to share your screen or do you prefer share yourself?
You can share if you would like. I guess if that's
okay.
easier.
I will try to do that for you if you wish to, but my
I can also share.
Okay, let me stop sharing. Yeah.
Okay.
All right. And if you guys have any questions, please use the comments button. Do let us know if you have any question. Go ahead, Andre.
Okay. So let me try this out. Okay, well, how do I go back to the, okay. All right, so hi everyone. So basically oh dear, it's like moving too fast. Okay, me and Shibu are going to present the performance stuff. So just to go over an overview, hopefully everyone is seeing this webpage. About the repos. So this is all the different, I just added a bunch of different links for what we were referencing when we were trying out the test. So like the first link basically tells you exactly like what the instructions are and how to run these benchmark tests. And so if you just go to that webpage, we'll go over this in more detail during our demo, but just to see an overview, it explains like how to test everything, how to set up your environment and what to do. And then we also found out for comparison's sake, there's a Linkerd test and an Istio test. So you can verify your results just to see what the difference is between Linkerd, a competitor, Service Mesh, and Istio. There's also 2 load generators that we were using. And so there's the FortiCode load generator and the Nighthawk generator. And I've added links there to talk about how the different load generators work, and you can find details about the options and such of the commands you can run. And then just as a general information, the performance tests are right now just running on the sidecar environment. That's because we found that with the ambient or the sidecarless mode of Istio, it seems to be we need to make modifications to these performance tests, because the way the performance tests currently work is that they're going to send using the load generators to the sidecar directly using the ports, or to just the application itself. But the way ambient works, it doesn't seem like it intercepts at a different point in time to transfer for the ambient or sidecarless Istio. So you're not getting the right results for the performance test, because the load generators aren't able to target a difference between the two of them. So we're continuing to work on that. Okay, and then, all right, here's a look at our requirements. So the real requirement that we have right now is just that you have 32 vCPU in terms of hardware, and that you have an environment that you can test on that runs Kubernetes. So I specified basically what we have currently running, and some information that we run into, like about the environments. So in general, most environments work without user intervention. Once a user has kube running, then they just have to install Istio using the scripts that will be provided in the benchmarking performance test. And then we're using an environment that Linkerd also runs their tests against, the Equinox environment for bare metals. But you should note that if you go to a different cloud provider like Google or IBM, or you use a different bare metal, your latency results will actually change between each different environment. It can actually be quite drastic in some cases where they've done a lot of optimization on their environment, or they haven't installed many things in their environment for security purposes. So we do notice that the more security you add, the more latency you add to everything, because everything's being checked. Then the other thing we've noticed is that the only thing that's really unique to everyone is the storage configuration. It seems like every cloud provider has their own method of how you're going to do storage, and you need the storage for storing your metrics that you'll be getting from the performance tools. So that's the other main thing that you have to be aware of. And the other thing is, if you have an M1 Mac, it doesn't quite work, because the scripts and everything that are running do look at your environment. And so we found that you can either, what we've done in this environment is just spun up another node that we use just for running tests. It's just like a smaller node. And then all it does is just have an environment that we can make the commands to. And then you'll need 3 compute nodes, because you need some HA proxy or high performance availability to test them more like a production environment. And then we have 1 Kubernetes controller node. And so that's just the environment. Okay. And here's an outline of the configs that we'll be running. So I just want to go over this, and then so you will demo how it works exactly. So we're basically having 2 things that we're running. One is the Istio stats, which is on the right-hand side. And then we're running a baseline metric, which is on the left-hand side. And so you can see that we're going to run connections at 2 connections for connection 8, connection 16, 32, and 64 connections. We're making 1,000 requests per second. And we're running these tests for 240 seconds. The longer you run, the less noise you'll get. For our demo purposes, we're going to run it really, really short at the minimum of 92 milliseconds, just for the demo purposes. But we found through multiple testing that a duration of 240 seconds seems sufficient. We don't get that much difference after running for like 5 hours versus 240 seconds. And then the size of our requests are 1024 bytes. And then these are different labels below to tell us how we want to send the traffic. Do you want to send to both sidecars, no sidecars, just run the baseline? Do you want to have MTLS or no MTLS? Do you want to have jitter, which means like we're going to burst the traffic, or do we want a more uniform traffic? It was decided that a more uniform traffic would be more like how the real environment is. Less jitter would be better. So we've turned off jitter, which is different than in the past. So 119 and previously there was always jitter, and now 120 and beyond, we will use a uniform distribution. Yeah, and it's time for our demo.
Okay, yeah, sharing my screen, please.
Yeah.
Wow, I didn't expect a live demo, so good luck.
So yeah, this is the documentation for the testing. So as Andrea mentioned, I'll be going through the demo on this test environment. So I already have these packages, these prerequisites installed in this environment. So Python 3, ppm and Helm, and we have the cluster. And this environment is still 1.20 installed already, and that's part. So if you want to install Istio, you can go through that link. So for the performance testing, we'll be setting up, running these scripts to set up the actual testing environments. And what this script is going to do for us is that it's going to actually it's going to deploy our Firstio server and Firstio server and Firstio client, because going to create a namespace as okay. So let me say this is going to these are the environment variables we are going to need for the script to actually set up the environment efficiently. So it's going to have a namespace. You have to specify a namespace, the interception mode, the redirect or the browser. So we are using redirect here, and we are setting it to inject as true. So that's going to label the namespace um, as it's still enabled. So under here we have presently we are using two types of load generators, Nighthawk and Forshoe. For this demo, I'll be using Forshoe as actually. So under the DNS domain, I think for TLS start testing, so but I don't think they're actually using it. So then you can run the test, but I've actually set up the environment. So that's that. So for just to go through it. So as I said, it's going to actually the setup will actually create two namespace for us. Just want to show how it's going to actually so so this is the namespace that was created, two ports, and it has actually enabled Istio on the namespace. So that's the and actually created two deployments for us as well. So the Istio um the virtual client and so we have the virtual client and the virtual server. So and the pods are running as well. So because yeah, so we have all this set up. So as so this is what the script is going to actually do for us. It's going to set up all this for us. So and we have that already. So the next thing is to actually run the so okay, I said we are using the virtual so we are using the virtual load generator for this demo. So and the next thing is prepare our environments to run the um, previously shown configuration, the one Andrea showed us the earlier. So if I go to this directory now to set up my Python environment and install and this. So this is going to actually install all the necessary tools for the scripts, for the performance script and the plotting of graph later on. So that. So now the actual thing is to run the performance test. So and to do this for the sake of this demo, as I said, I'll be I'll be using the first show. We have two types of, we're using Nighthawk and first show. So for this demo, I'm using first show generator. So I'm going to specify that. So yeah, you can see that's a must for us to have before we can actually run the demo, run the performance test rather. So then again, these are required labels as well. So we have to specify the connection, the query per seconds, the duration, load gen type, the one I just set up now, and the telemetry mode. So as we saw in the files that Andrea showed us earlier, so all these have been specified in the config files. So so all these have been specified in this latency file. So I'll be running this command now. So for the sake of this demo, I'm only running two connection, just two parallel concurrent connection. So it will be super fast, and I can actually see what's going on. So
Yeah, I think we just have to change the namespace to 2 pods instead
yeah,
of
2 pods. Yeah.
Yeah.
So I have to specify the namespace as well. Sorry. And
And I think, yeah.
run the command again. Yeah. So what's going on here is that we can see that we are running the test in this namespace, to post namespace, and it's using this partial client pod. The container is uncaptured, and the partial load we actually specified, and the jitter is false. So as she mentioned earlier, we are turning jitter off for this 1.20 because it actually make Istio very slow. And yeah, we're actually turning on come true and non-captured true. So according to Fascio documentation, um, having both of them, I quickly want to show something there. Yeah, having uniform true, it is recommended that when we are having uniform true, we have no catch up true. So what non catch up is actually doing for us here is to it won't overdo for us if this if the load is not being, if it's not up to what we are specifying, and if it is overdoing it won't actually go beyond it as well. So and we have our connection here too, and the query per seconds. So the minimum we can run is actually 93 seconds. So to have the for for any other environment, if you want to have if you want to know the maximum query per second, the maximum QPS you can run, so you can actually specify this to be 0. You specify 0 here, and maybe you put the duration to be 30 seconds. It's going to give you the maximum QPS you can have in the environment. And according to first shoot documentation, it is recommended to go for the 75% of that maximum, to run at maximum 75% of the maximum QPS. So you can see here, so this is completed. So see, it's done after 1 minute 3 seconds. It's made next 2 minutes 7 calls, and yeah. at 999 per nexus, almost 1000 kbps as we specified. So what it does after each of the connection successfully run, it's write the data, all these points, all these points data, it writes them in a file in which we are going to use each of these data that is being written in this file for our graph. See how it's actually the latency actually is. So for the sake of this demo, I'm only running two, but I have a similar one I ran here. So you can see for here it's run two. This is for two connections, for four, and so on. So after all that has been done and the data for each of the connections is written to the file, so what we actually do next is to gather the metric. So we have to gather all the data with all the data points together and see how latency is. So to do that, we have to actually set the ingress to set the virtual client URL. So and to do that, we are setting it through the ingress. So if I run this command now, should set that up. So yeah, so we have to set up the virtual client and also the Prometheus URL. So I've done this before. This can going to give an error that's sorry, the port is already in there.
Mute you. Just a quick time check. We're getting towards the end. I
Yeah,
just want to make
sorry.
sure if you have any
So
summary, there's a
yeah,
time to
so
show.
here, yeah, exactly. Sorry. So here we have yeah, these are the data that has been written. So it looks like this. So this is how the actual data looks like, and if we want to plot the graph, the final graph is going to actually look like this, and these are the data points that's going to be on the graph. So if I stop sharing, and you can see the actual result on the slide. So that's it.
Okay, great. Does the graph generate automatically for you too?
Yes, it
Yeah,
does.
yeah.
Nice.
Yeah, so let me share my screen real quick again. Yeah, so thanks to you for that wonderful demo.
Yeah.
So basically for just the last part of it, this is just the results like if we had run with all the connection points and the longer duration and everything. So basically you can see for the P90 graph that we only have like a 0.25 difference in latency for milliseconds between the baseline and Istio with stats. So basically there's no mesh, but MTLS on the baseline blue line, and the orange line is showing Istio with stats because like we mentioned before, there's not much of a difference when we run with and without stats. You don't see any latency. So having two lines on top of each other made no sense. And then at the P99, you can see that it is a little bit more latency, but it's not that much, 0.5 versus 0.23 or something like that. And so that is our conclusion. So it looks like Istio 1.20 is doing much better. And the reason you're seeing a big difference between 119 and 120 is because you've added that uniform. So if you go back historically, you'll see that the differences are larger because we had the jitter versus the uniform distribution for our load generation. And then
That's great news. Yeah. Well, I want to say, thank you. I think the entire community, thank to both of you, Andrew, especially your leadership, and Shuya, and doing the hard work, be able to get back the performance and scalability data and restore that page for the team. So much appreciated. it's really exciting to see the numbers, look so good on 120, the latency number. Yeah. All right, I think we have a few minutes left. I want to ask the audience if you guys have any questions or if you guys want to share any thoughts on 120, or do you guys have any future user community topic in mind? Please do let us know. Next time we will probably have another Istio steering committee member run this meeting for everybody. I saw Fasila is on, so maybe Fasila will help us run that next time.
Yeah, let's see.
All right. If there's no further feedback, you know where to find each of us on Istio Slack. Do let us know if you have any questions on today's topic. We're still looking for submissions for Istio Day. I think Fasila shared in the announcement channel. If you're interested in speaking at KubeCon and particularly Istio Day, do leverage the next few days to submit something. All right. With that, I want to ask if any of my speaker wants to say anything before we wrap up. All right. Thank you so much. And thank you everybody for joining. And thank you for our speakers today, Peter, Andrea, and Shuya for doing such a wonderful job. Thank you all. Have a good day. Bye.